So yeah, first of all, thanks a lot to the Siemens team for inviting Synera, and also thank you so much for having me on this virtual stage. My name is Ram. I'm the head of AI at Synera. My primary responsibility includes building the product, talking to our customers, trying to understand the problem more deeply, and also architecting the AI platform. And today I would like to talk about our value proposition, and that is with Synera, now every RFQ process can be accelerated 10x. And what we do is agentic AI for engineering. So that is what I would like to take on a overview today. But first, let's start with the challenges. Julian already mentioned a few of them, and I want to deep dive a bit more into them. So the overall overarching challenges that we see in the market are primarily three things. So one is definitely a talent shortage itself. We work with some of the top tier industries, and what we see is we need really specific talent for different engineering domains that have to be present. There is also the other side of productivity pressure of different other markets overtaking in the automotive space. And then all of it boiled down to bottlenecks, which is some experts missing, there is critical resources that are missing, and all of this pile up on a more overarching level. And what we did was we looked into, okay, how does this typical RFQ process work today? And that looks something like this. So there are different engineers involved per RFQ project. They involve a lot of documentation, a lot of alignment, and everybody has to meet a lot of times just to share their knowledge, just to provide reviews, and to actually execute engineering work. And of course, there is a lot of absence in between these, where just for the slightest approval, we have to wait for someone. And even drilling down a bit deeper into the actual problems, we try to search for, okay, what are the engineers actually doing every day? And that is in small to medium companies, but also large companies. And we found this resource actually from a part of Siemens. Almost 50% of time is just spent in meetings, 40% in kind of interruptions, and across different variations, we also see a lot of repetitive manual tasks, and also in general, inefficient collaboration was responded as a big problem. And this is where these are the unique problems that we try to tackle. So for the problems that are caused by interruptions and these repetitive tasks, those are the places where single AI agents can offer the highest value. And I will come to the section where we try to define what the single AI agent is. But the question still remains, what about the other collaborative tasks? The one that require meeting, the one where the processes itself are very inefficient. So therefore, we try to come with a hypothesis that we want to automate this collaborative engineering work, take out the repetitive tasks, and allow 50% of this engineering work that happens in engineering process become digital. So the idea is that every engineer gets an assistant, an engineering assistant, by which they can focus on the other important tasks and not worry so much about the repetitive tasks. So therefore, what we try to do is we see, can agents team up and eliminate these delays? Can agents not create the documentation and other engineering stuff? So the goal is, in parallel to an engineer, there is also the agentic representation of the most repetitive work. So therefore, we try to reduce these delays and overall execution time that happens in these processes. And with that, I want to introduce our agent. So typically inside Synera, our agents are collaborative. That means an engineer can go and give it an engineering task, and it can execute real engineering tools, knowledge, and come back with a response. And there are three components to this agent that we have. One is the brain, which comes from LLMs, and then we add instructions on top. The second important one is context. Every company has unique context. Therefore, we try to gather this knowledge in multiple form. It's not just document, but also logic, but also different rules and guidelines existing scattered across places. And then we also have a memory layer. so that even if something is not available, the agents can start learning. And the last but not least, we also have the tool layer. And tools is where we began to zooming in 5 to 6 years ago, and we call them workflows. So the workflows are essentially sequenceable tasks that involve connecting CAX or PLM, CAD tools so that they can execute actual engineering tools instead of having to predict them. And this is more like now a coworker or an assistant because it has the brain, it has the context, and it also has tools to actually execute tasks. Now, in practical, when we look inside the product, the multi-agent system would look something like this. So here we have more like a design to cost or a sustainability agent. And we can see that there is a supervisor, which involves a large language model. The same model also goes to the other agent. And inside each agent, we also give in the instructions along with memory and everything else. And the important aspect is also that specific engineering agent can call a tool. So every agent has one or usually more than one tool to execute the whole process. And I will also touch upon shortly on why we chose a multi-agent approach. But this is how it looks like inside the product after you build it, and the wires dictate which agent can talk to whom and so on. So once we build this agent, the end state looks something like this. So I'm gonna, yeah. So what we have here is the interface where agents can be called, and on the right side we have separately CATIA and the file explorer open, just to show how it works. So this multi-agent system, as you can see, it can do a couple of things. So CAD geometry, cost, also reporting. And now the user, typically an engineer, is giving it a task to do. So a manufacturing analysis, which is typically a very repetitive task. And now what we can see is that the supervisor agent calls the geometry agent. And the geometry analysis agent is going to start to use its tool. It's going to figure out by actually calling an engineering tool what are the different analysis result. When it faces an error, it also self-corrects itself and goes to the next tool. And now it's running a forming simulation. Now, inside each of this execution, there is a callable automation given as a tool to every agent. So that is how they come to this analysis. And we can see that there are different conclusions that each agent come, and then the supervisor makes an overall summary. And what we see here is it's going to find for me as an engineer who's involved in the process some reviews, which are fitting the actual guidelines that my organization has. So now with this assistant, I can go back to my CAD, not wait for another colleague to review this information here, but rather change it myself and keep doing this process again and again. What I can also do is do multiple things. So it's not just one thing, one task I can do. Now let's say I need a CO2 analysis. So now the agent will also go ahead and start doing it. So this is essentially how engineers interact with our platform. And there are different scenarios that, depending on whatever tools and agent we have, that this overall system can execute and provide me fast reviews. So that is essentially how we put it into production. But now let's go into how do we build this specifically for RFQ. Like Julian mentioned, we do different processes. RFQ is one process. We also do design to cost, a lot of other engineering processes. But I want to now take a moment to describe how we specifically handle RFQ. So in our understanding, we want to build an RFQ with the goal that the process is completed by agents predominantly, and humans are in loop to provide review or to take some novel decision. So typically we start by asking, how does the process look like today? Who are the people involved? And then depending on what is safe and feasible to be given to agents, we start building the agent. We then build the supervisor, and then we connect the agent so that all these can work together and call the tool. So a simplified RFQ system typically looks like this. So when every RFQ comes to a customer, they have to do some kind of analysis where we see if there were already existing parts. And if those already exist, the goal is to take them, do an assembly planning, for example, So see what kind of joining methods or what other engineering practices we have to do. Also plan for purchase. So this is also a very explorative job where we have to see to propose an overall cost-effective structure. What would be the different location? And then there is also cost analysis involved. So in a way, all of these are interlinked. So sometimes it looks linear, but in reality, it's often non-linear processes. And that is why an agentic approach works, because there will be a lot of iteration, not just on a simulation level iteration, but also actually on the different context, that what happens if I change one scenario. And one question that I want to address is also, we get asked a lot, okay, why do you go for a multi-agent approach? What's the pros and cons? And therefore, I want to show our take on it. So agents for ourselves, they combine these two superpowers. For one is definitely having this large language model, which is a generally available knowledge. It also has a memory layer, and therefore it can learn on the fly. The second superpower that we give our agents is the workflows, because still this RFQs, the accuracy of it still needs to be done by typical CAD, CAE tools, Excel, other simulation platforms, and so on. So there is already these two capabilities that a single agent has, but and that is great for automating expert scope and isolated tasks. That means when I pick one domain, that single agent can learn on the fly. But what we observe is that, which is also now the approach in the overall agentic world, is that these kind of single agents, depending on the model, they fail if it involves too many domain or it involves too many tools. And therefore, we go on a multi-agent approach where we combine different intelligence and model capability. So not every agent needs to have the same model. And this will also allow that we can feed this overall system as much context as possible. So now the great aspect of it is that it can automate more complex tasks. It can go multi-domain, which is typically what we see in RFQ. So it involves different kind of analysis, not just one engineering task. So it involves manufacturing engineering analysis, design engineering analysis, also cost engineering. But the con of this approach is there is a randomness factor everywhere. If the tools don't get properly called or if the tools get skipped, then some part of the accuracy is compromised. And that is what we try to ensure in our platform. But also one other way to solve is to go with this whole supervisor that takes care of the end output. So the supervisor agent is more of this overarching agent. It really doesn't need to be one that gathers engineering knowledge or even need to use a workflow. What it has to do is coordinate the process flow, activate the required agent, and be responsible for the final output going back to the user. And this also then needs to know that, okay, what are the different agents that I have as a supervisor, so that the interaction with the human also gets easier. So now when we look at that original process and we try to see how would that look like in reality, this is how it could look. So there will be a RFQ manager as a supervisor. There is then the commodity analysis. We can connect to tools like NX or SAP. Then we can also have the assembly planning, where the goal would be to see, okay, what are the different options available? What are the different trade-offs? We could also connect to any other web tool to do this purchase planning, and then connect to tools like Facton or maybe even other team center-based costing tools to do cost analysis. So this is a simplified representation, but in reality, the agent will have multiple tools. And this is a representation of a typical RFQ multi-agent system that our customers have in the tier industry. As you can see, there is the RFQ manager, and it receives an RFQ package. And this is typically uploaded by a sales engineer or a technical sales engineer. And now what happens is this RFQ manager knows, okay, I have a requirements analyst or an agent, I have a product agent, a process agent, and also a cost agent. And the more important information is that each agent has a tool, a deterministic tool to actually execute tasks. So for example, the requirements agent has a tool to extract data, and it could involve a logic of what we call nodes. So it could be a logic where the step is described in nodes. It could be a integration to another tool to actually do the job. So each agent is responsible for certain input, certain output, and every agent has its own bunch of tools. And like I mentioned, it's not just one tool, it's multiple tools. So depending on the flexibility of the request, the agents decide for what tool should I use to get this job done. And at the end, all these agents work together so they can all talk to each other, collaborate like reviewers, and then the RFQ manager summarizes the whole response and gives an answer back to the same user. So this is how we typically enable agentic AI for engineering. So with tools, manual engineering tasks are already repeated or automated. So repetitive tasks are automated. With an agentic approach, we make sure that there is also a lot of decision-making ability for the agent. And using this multi-agent approach, the communication and review times are also reduced. And that is how we make RFQ processes 10x faster. And we already have, we have been working on this for the last 7 years. So we have customers not just from the RFQ tier 1 industry, but also other customers who have our agents in production, in manufacturing, in cost and value engineering, but also in different other domains. And this is also possible because we have a very strong partner network. So we partner with the leading technology partners like Altair, AWS, Hexagon, and also Siemens, and multiple other partners through a very strong partnership and marketplace capability. So that is Synera. We make agents a reality for engineering. And if you have any questions, I'm happy to take them. Or you can also get to know more about us by visiting Synera. So that was all I had to say, and I'm looking forward to being in touch with some of you after this call.